For an example of how these linearizations actually work, I'd like to consider the following problem. We're going to find the linearization of f of x is equal to x cubed at x equals 10. We're then going to use this linearization to approximate 9.99 cubed as well as 10.02 cubed. So as long as we're selecting numbers that are relatively close to 10, we should be okay. Once we're done, we're going to verify our results with a graphing calculator just to see how accurate these linearizations are. So with that in mind, the formula that we had for a linearization is that the linearization is equal to f of a plus f prime of a times x minus a. In our example, we're using the function f of x is equal to x cubed, and our a value is 10. So first, let's find f of a. F of a in this case would be f of 10. So f of 10 would be equal to 10 cubed. 10 cubed would be 1,000. We're also going to need a derivative for this formula. So f prime of x would be the derivative with respect to x of x cubed. That, of course, would be 3x squared. Then actually plugging in x equals 10 to this derivative, we are going to get the slope of the tangent line. So 3 times 10 squared, that is equal to 300. Therefore, the linearization that we're talking about, linearization is going to be equal to 1,000 plus 300 times x minus 10. Now, the interpretation of this linearization, and I'm just going to go ahead and leave it in this form. The interpretation is as long as we are near x equals 10, what we're saying is that x cubed is going to be approximately the same as 1,000 plus 300 times x minus 10. So if we can figure out a good value of x to plug into either of these, we can get a pretty good approximation of what that number cubed is. So to actually interpret what we said earlier, we're going to try 9.99 cubed and 10.02 cubed. We'll say at x equals 9.99, what we're saying is that 9.99 cubed is going to be approximately equal to 1,000 plus 300 times 9.99 minus 10. Now, cubing this number doesn't seem particularly fun, but honestly, this isn't going to be too bad. So this is going to be equal to 1,000 plus 300 times, performing this subtraction will be negative 0.01. That is 1/100th, and 1/100th of 300 would be 3. So this is going to be 1,000 minus 3. So 9.99 cubed is going to be approximately equal to 997. Just wanted to verify this, and we'll see how accurate our prediction is. So 9.99 to the power of 3. I don't know how well you can see this with the glare that's on here. Also, I'm not sure how to turn down the brightness. Oh, that was helpful. There we go. 997.002999. And our prediction was that it was about 997. I'd say we did pretty well for ourselves there. Now, similarly, I'd also like to do 10.02. So at x equals 10.02, what we're saying is that 10.02 cubed is approximately equal to 1,000 plus 300 times 10.02 minus 10. So with that in mind, performing our subtraction first, since it's inside the parentheses, that'll be 0.02. 0.02 times 300 is going to be equal to 6. So this will be 1,000 plus 6, or 1,006. And once again, we can use our calculator to verify how good our approximation is. So 10.02 to the power of 3. Hold this up and hopefully we'll be able to see it okay. That is 1006.012008. So accurate to the first decimal place at the very least. So that's a pretty good approximation.